So before I jump into this very important topic about millimeter wave and the spectrums that are going to come in for 5G, it is very important to understand where 5G is transforming into. There were use cases in the past, like in last 2 to 3 years when the 5G came into the picture. We started with the EMBB with mobile smartphones. There were some use cases related to video surveillance, but eventually now the 5G is transforming into a much bigger thing. And it is very important that while we are talking about new use cases, we are talking about a good amount of traffic that is coming into the network. And this is where the new spectrums have to be evaluated, and millimeter wave is one of them. Um, Before I jump into the millimeter wave, as I was explaining, now we started on the 5G from the 2018 onwards when release 15 came into the being. There were three pillars of 5G, mainly comprising of EMBB, URLLC, and massive machine time communication, which mainly was handled by the NB-IoTs and the LTMs. This was transformed in release 17 with an extra pillar. We call it NR Lite or AKA Red Cap as well. I tried to club it with the massive machine type communication and also with the EMBB, and not with the low latency because it has more to do with the EMBB and the MMTC. So when it came out as NR Lite, it was somewhere around 100 Mbps speeds, where I can reduce the complexity on the device chipset, and also I can handle good amount of IoT use cases. So it was somehow more closer to the EMBB and the massive machine type communication. Now in release 18, that is supposed to be released in 2024 half one, the triangle will transform into a hexagon. And in the hexagon, the EMBB will turn out to be EMBB plus. So which means I'm talking about more speed. So in release 18, the triangle has transformed into a hexagon and it starts from the EMBB plus. So the throughputs have improved going ahead from the release 17s, where we are talking about more clubbing, more spectrum, and we can achieve higher speeds. We are talking about how high precision positioning via with the help of 5G. We are talking about less than 10 centimeter for 90% of the time. We are talking about URLLC plus with the addition of more reliable features, multi-TRP communication. We are talking about AI and automation. Now, this AI and automation has to run all the way in the RAN network as well, which wasn't the case in the previous generations of the releases of 3GPP. But this is something that is coming into the picture. Massive machine type communication, so transforming the NB-IoTs and LTMs into a single technology, which is 5G, and with the help of different subcarrier spacing. And then last but not least is the low complexity devices, which is the red cap, and the additional addition of the passive IoT as well. So this will help in rolling out good amount of low activity IoT devices. And then on top of this is what we call it as a greener network, a sustainable network, and then a secure network, which has to be ensured for each and every pillar of this hexagon. Now jumping into the so now jumping into the traffic trends, because this is where it will drive our strategies that we need to consider new spectrums. And I took this from Ericsson Mobility Report that was published last year in November. What we see is that there is a CAGR of approximate 17 to 21%. There is a growth. In some markets, it is a linear growth, and in some markets, it is exponential. So in some markets, you will notice that the growth is somewhere around 30 to 40%, and in some markets, it is slightly less. But on an average level, it is somewhere around 17 to 20%. And then there are markets where, for example, in 2024, we will realize that the 5G traffic ratio has almost reached 50% of the total traffic. And in some markets, we are going to see in 2025 and 2026 onwards. Now, this translates that 5G is picking up traffic. If I assume, if I take the Pareto 80-20 ratio, then I will see that the 20% of the cells of those 5G networks, the utilization of 5G is exceeding 50 to 60%, which means that there is good amount of use cases already coming into the 5G networks. Now, in terms of the spectrum, if I dig down further, And I see that when all I can say majority of the 5G networks when they started their deployment, definitely the strategy is to start with the coverage layer, to have your primary layer which can be considered as coverage slash capacity layer, and then this is where your majority of the capex goes. And this is where it started from the sub 2 gigahertz and the sub 4 gigahertz. I have mentioned like spectrum, considering that majority of the operators they must be operating. For example, the sub 2 will be the NRFDDs, which is ranging from 5 to 20 megahertz. Then you will have the NRTDDs in the C bands and in the N41, and it will range from 50 to 200 megahertz as well. Then we will have within the domain, based on the recent conclusion of the WRC 23 and the finalization of the upper 6 gigahertz, the 600 megahertz, and from that 600 megahertz, maybe some operators can take 300 megahertz as well. But this is a future spectrum, and this is what we feel that will come in back in somewhere around 2026 and 2027, depending on the ecosystem readiness. But what we have today in our hand is the FR2 band, and the more specifically band is the millimeter wave band. Now, this band comes in a chunk of a bigger bandwidth. It comes in a range of, for example, 600 to 1 gigahertz as well. And because of this bigger chunk of bandwidth, we have the flexibility as an operator to deploy it as a downlink biased kind of a deployment, or it can be uplink biased deployment as well. Now, when I say we can deploy it as uplink biased as well, this was never possible in the you can say in the FR1 or in the C bands, because of clubbing or coordinating the spectrum with the other, or the patterns with the other operators as well. But in the FR2, it becomes much more easier to consider the uplink biased as well. So this will help the operators to deploy millimeter wave in scenarios where you are having a kind of uplink centric use cases. So you can deploy, for example, if you have video centric or you can say downlink type of use cases, then TDD pattern like for example 3:1, which is 75-25 pattern, can be utilized, and it can provide good speeds of around 4 Gbps on the downlink and 600 Mbps on the uplink. But if you consider the uplink bias patterns, you can go up to 2 Gbps on the uplink as well. And this can help, for example, the streaming kind of use cases on the uplink, like video streaming. Apart from the throughput and capacity that we discussed in the previous slide, one important aspect of millimeter wave is it brings a good flavor of latency. It improves the latency as compared to the 3.5 gigahertz, and this is the main the basic physics of the deployment. That in 3.5 we are talking about subcarrier spacing of 30 kilohertz, whereas in millimeter wave we are talking about 120 kilohertz. So definitely this will improve my time domain by 4 times. So what I did was that I chalked out the RAN latency and I ranged it from min to max. So in case if I try to send a ping message from my device all the way to a server and back to my device again. So this will come. So I took only the RAN part, and I saw that in the 3.5, it will be somewhere around 9.5 millisecond. And if I add the SR periodicity, which is the grant periodicity, the grant allocation periodicity, normally it is defined on the RAN end, which is somewhere around 10 millisecond. It is the minimum value. So the max can go up to 19.5 millisecond. But if I take millimeter wave, the RAN latency will shorten drastically by almost 4 times, and this the min comes out to be 2.3 millisecond, where the max can go up to 12.3 millisecond. And this shows that I am ready with the millimeter wave spectrum to handle kind of use cases that are looking for low latency. So just to give an idea that millimeter wave in terms of latency, it is a much better option as compared to the C bands when it comes to low latency use cases. Now, if I combine the from the previous two slides, what I see the characteristics of millimeter wave, that it is good in terms of capacity and speeds, it is good in terms of low latency. If I grade them as A and B, I see that in terms of use cases that I can handle is I talked about surveillance cameras, so I put it in a category of A plus B. So I need low latency, I need high speeds, I need good amount of capacity. This is where millimeter wave can be very beneficial. Also, a very important use case for millimeter wave is the deployment in a crowded events or in a place you are, for example, in arenas, in concerts. And what we have seen is that the uplink biased or uplink traffic is normally 50% of the downlink during the events. Now, normally the C bands are run in a fashion of 80-20 ratio, where 80% of the time I'm using downlink and 20% of the time I'm transmitting on the uplink. So the uplink capacity becomes very small to handle such a huge crowd of traffic. But with the help of millimeter wave and with the help of the uplink bias kind of a deployment, I can say that it will become very easy to deploy or to handle such kind of traffic. And by the way, just to quote here that there are a lot of you can say deployments across the world. In US, I have seen a lot of press releases where millimeter wave has been deployed in stadiums, and I've seen some third-party benchmark reports as well that millimeter wave has been performing really well in terms of the uplink speed per user. Now, the other one is the AR VR. It is a long way to go ahead in the AR VR, but this is something that millimeter wave can come into the picture. Today, the AR VR doesn't require higher speeds. They need only 100 Mbps. But when we talk about 4K and 8K in the resolution in the AR VR, then we will be requiring very high speeds, and millimeter wave can be utilized. And the last but not least is the smart factories, where we talk about low latency. We talk about low latency only. I have clubbed the A part, which is the capacity or the speed as well, because while you maneuver the cranes, you need some cameras as well, and for that you need good amount of speed as well. So all in all, there are good amount of use cases in terms of consumer and enterprise that can leverage on the capabilities of the millimeter wave. Now, apart from the consumer or the enterprise use cases related to the eMBB, a very important use case that can be considered for millimeter wave is the fixed wireless access. Now, there has been a lot of debate about the fixed wireless access versus the fiber infrastructure, because we always say that the fiber is the default connectivity for each and every networks, for each and every consumer. And there is no denying on that yes, fiber can provide me a reliable and a scalable connectivity. But then the fiber comes with lot of challenges in terms of the capex. It comes so there are, for example, areas like suburb areas, there are rural areas where even today there are a lot of networks and operators are reliant on the coax and the on the twisted pair, and fiber availability is not in abundance. And this is where millimeter wave comes into the picture. It can provide handsome amount of throughput to the households, I can say. Also, there is a lot of demand that has been picking up for the fixed wireless access in terms of backup. So there are SMBs and there are premium customers who in the past have seen that there are a lot of outages related to the fiber cut, and they are asking operators for a backup solution in terms of wireless. And this is where fixed wireless access also comes into the picture. Uh, Also, I wanted to mention that in terms of the fixed wireless access, there are markets where there are some networks, they don't have strong fiber penetration, and to cannibalize the ecosystem or to cannibalize the market, they are trying to sell fixed wireless in a you can say in a much more cheaper option as compared to the fiber. And this has been disturbing the markets in many areas and across the globe. And also, there are some, you can say there is a mandate by the government in many EU markets where they are looking for 1 Gbps speed per household in 2025 and beyond. Now, as I have been seeing, and this is what we can say, that the FTTH penetration in Europe, in majority of the markets, except Spain and Portugal, that is lesser than 50%. So, which means that I have a bigger chunk of an area which can be easily served by the fixed wireless access, and millimeter wave can help in those cases. So as I have been saying that millimeter wave can provide fiber-like connectivity, and on top of it, there are a lot of I can say there are a lot of trials that have been done by the tier one vendors, and what we are seeing that by utilizing my existing, you can say, deployment, I can efficiently extend it up to greater ranges, because there have been concerns on the millimeter wave coverage, and it has been seen that the downlink and the uplink path can be balanced with the help of high power CPEs. And trials have shown that 1 Gbps speeds can be reached up to 11 kilometer. So I have mentioned about the CPEs. Yes, the high power CPEs are there in the market. There are CPEs of different flavor for millimeter wave. There are CPEs for the external mounted antennas. There are CPEs which are kind of you can say mesh antennas that can be just pasted on the window of the room, and then you can just extend your cable to your router, and you can get very good speeds. And then there are internal CPs, but very advanced kind of internal CPs that are coming with high EIRPs, and they are having 360-degree antennas with very good smart envelope detection for the millimeter wave. So all in all, the industry has been working a lot on the fixed wireless access to be adopted with the help of millimeter wave. Uh, there has been a lot of evolution in the millimeter wave coverage. Yes, there had been reservations at the start when the 5G was picked up. When this deployment started, there have been markets where millimeter wave is already in use. The traffic on millimeter wave is very less, but this can be enhanced. And the reservation is mainly in terms of the coverage. So there are a lot of enhancements that have taken place. The physics applies, yes, that we get the higher chunk of bandwidth, but we get the lowest coverage in terms of the high band. But in terms of the enhancements that we are seeing from the vendors is, number one, it can provide us dual connectivity, where I can club the FR1 with the FR2. And when I club the FR1 with the FR2, what I can do is I can transfer my uplink data on the FR1, on the lower spectrum. And this is where I can further extend my FR2 coverage. To further improve this one, there are so in 2024 there will be some products in terms of ecosystem that will be supporting carrier aggregation as well, by clubbing the FR1 with FR2. And apart from the dual connectivity, which was able to extend my FR2 coverage, I can further extend by transferring the control part of the uplink and downlink from the FR2 to the FR1. And this is where I can further extend the FR2 coverage. Then the third point is the high power CPEs. We already discussed in the previous slide. There are some indoor CPEs that they can go up to 55 dBm EIRP, so they can improve the link budget between downlink and uplink. And then there are outdoor CPEs that can go up to 46 dBm as well. There is a fourth item which is for the future study. This will be adopted, I can say, for the 6Gs, and that is the reflective intelligent surface. I have pasted this a snapshot, a link, you can say a simulation. Maybe if you will be able to focus, the red is the strongest level and the blue is the weakest level. So this is a transmitter. It is transmitting within a room. So within the room, I'm using a millimeter wave transmitter. I can easily go all the way to the next end of the room. But in case if I need to go to the other corner of the room, I will not be able to do that because of the millimeter wave constraints. But if I will put a reflector, then I can somehow reflect by changing the phase of the signal. I can go on the other side of the room, and then over there I can put another reflector, and then I can reach the corner that I'm looking for. So this reflective intelligent surface is something that there are some trials done by the tier one vendors, and this is a study item that is being done right now, and it can be adopted for the 6G. And if we can imagine it, that it can be utilized for the indoor environment, so I can use millimeter wave in the indoors. And because we know that there will be a lot of obstacles and a lot of propagation losses, so a reflective surface can help me in that. And also it can be applied in the outdoors as well, where I am talking about dense urban areas, and I can, based on my 3D maps, I can plan these reflective antennas in a very specific way, and I can utilize the millimeter wave in a more efficient way. Another use case of millimeter wave is in the vehicular positioning. We are talking about there are phases in the automation of the vehicles, but when we talk about the last phase of the vehicular automation is the autonomous driving. And when we talk about autonomous driving, we talk about very accurate positioning of that vehicle on the map. And this is this is where industry is talking about something somewhere around less than 30 centimeter for 90% of the time. Now, currently, all the trials or all the current, you can say, deployment that is there, there are some, you can say, there are some references in the industry. Some references are from the US market as well. They are currently reliant on the GNSS based positioning. Now, the GNSS based positioning, it comes with not an accurate kind of a deployment. It comes with accuracy of 20 to 50 meters, depending upon the areas, but it can be further improved by real-time kinematic, where it can bring down the accuracy in centimeters. But when we talk about deployment in the in the dense urban areas, in the dense urban, the multipath increases, and when the multipath increases, the estimation of the positioning becomes slightly weaker. The noise increases. And apart from the multipath, the other challenges with the GNSS is the jamming and the spoofing as well. So GNSS is not a good deployment for vehicular automation and vehicular autonomous driving. And this is where 5G can come into the picture, and 5G based positioning can be utilized as a priority one kind of a deployment, and it can be deployed in a hybrid fashion. So, for example, in the suburb areas, I can rely on the 5G based positioning by the NRFDDs and the NRTDDs on the FR1, and in the dense urban area, I can rely on the NRTDD from the FR2, which is millimeter wave. Now, the millimeter wave, it brings a lot of advantages in terms of positioning. I have listed down four advantages over here. The first one is the line of sight properties. We know very well that the millimeter wave, it is not good in terms of the non-line of sight. In terms of multipath, it is almost zero. It is negligible. So because of its LOS line of sight properties, the signer is very good, and this helps the receiving end to estimate the location in a much more efficient way. The second is because of its low latency, I'm able to send the sequences in a much more efficient way rather than in terms of, as we said, that in the NFR1, it is 4 times higher. So the low latency helps in locating the user in a much more efficient way on the map. The other is the high directional beam forming, because in millimeter wave we are clubbing good amount of antenna elements, and this somehow generates much more penciler beam in terms of TX, and also in terms of the RX, or in terms of the TX from the CT or the UE side as well. So that helps in the angle of arrival and the angle of departure as well for estimating the positioning. And the last but not least is the carrier bandwidth. So in the FR1, the maximum carrier bandwidth we can deploy is the 100 megahertz, but in the millimeter wave, we have the choice to deploy 200 megahertz and 400 megahertz. And by spreading the pilot reference signal, which is the sequence that is required by the device, if I will spread it over 200 and 400 megahertz, then somehow I am trying to ignore the fading or the external interference that comes. It can be severe on the 100 megahertz, but if I spread my signal on the 200 or 400 megahertz, this somehow avoids, or you can say it reduces the external noise. So the key takeaway from our session today is that we are seeing that there are good amount of use cases that are coming in with the help of release 18, and this will somehow increase the traffic on the 5G networks. As I mentioned, if I apply the 80-20 split, there will be 20% of the cells in our 5G networks where the 5G traffic is really picking up. It is exceeding 50% of the utilization, and we require new spectrums. We require spectrums that can provide good quality of experience. So we have seen that if I see on a global level, if I average it out, the CAGR, the compound annual growth rate, it is around 17 to 21%. But if I zoom in, there are some markets where it is further increasing from 30 to 40% as well. So millimeter wave can help in those aspects. And as I have listed down, there are good amount of use cases in consumer in a domain. There are good amount of use cases in enterprise domain that can leverage on the capabilities of millimeter wave. Millimeter wave is very good spectrum for the fixed wireless access, where, as I said, that there is a mandate by different governments to provide 1 Gbps gigabit society, and millimeter wave can help in those aspects where C-band is very much limited in terms of handling the higher speeds. And last but not least is the positioning, that millimeter wave will become a choice, the prime choice of deployment in dense urban area for the 5G position. So that's about it from my side.
Wow, thank you. That was a lot of information. We've got some great questions, but we're already running slightly late. Could we maybe just answer them briefly? And if you wish, Bilal, we could forward the people's details to you if you want to take them offline. The first one is, will UL-centric millimeter wave be affected by other mobile operators if they are downlink centric?
Now, this is a very good question. As I was mentioning, that because in the millimeter wave we get this flexibility of higher chunk of bandwidth. So, for example, if I take 26 gigahertz, 26 gigahertz is spanning across 3 gigahertz. Now, in case if I consider a country where it is where there are three operators, and if I choose to deploy 400 to 600 megahertz, and then I put a spacing of 100 to 200 megahertz in the middle, then it becomes a very flexible to deploy uplink centric TDD pattern, where I will not be jeopardizing, or I will not be interfering with my neighboring operators or even cross-border interferences.
That was quick, very good. And do you see any way of saving capex with mmWave antennas due to the forecasted need to increase its number per area unit? If you need to increase it's a bit of a trickily worded question. So can capex be saved if you have to increase the number of millimeter wave antennas per area unit?
If I get this question, the question is related to the antenna aperture, where if I club more antenna elements to reduce the capex, yes, this is possible. This is already being adopted by some of the vendors, where they are increasing the antenna sizes to transmit with higher power, definitely keeping within the limits of the ionized emissions.
And finally, to go to a different member of our audience, what about backhaul applications? Do you see millimeter wave being useful or less beneficial for that application?
Now, when we talk about 5G, we talk about higher speeds, and we always say that for the backhauling, it is much more, I can say, priority one should be to utilize fiber as much as possible, because on the 5G cellular end, we are looking for higher speeds. We are looking for higher capacity. But in case if fiber is not available, then we can rely on microwaves as priority number 2. And then as priority number 3, we can consider millimeter wave as an integrated access backhauling as well.
Thank you very much. Bilal, if you'd like to, you can use the Q&A channel to engage further with our questioners. I'm just very sorry that we have run out of time, but thank you very much indeed. Very interesting.
Thank you.
Thank you.